Okay, our final simple machine is kind of interesting. It's a simple screw, and it's really two simple machines. If you think about it, you would apply force out here on the head of the screw, and that out here, and you'd start turning it around or something, and that would turn this right here. Now, what is that? That is a wheel. That's a wheel and axle, right? That's a wheel and axle. The other thing is you have these threads that circle around the axle. It's really, if you look at it really closely, it's an inclined plane that wraps around. So a screw is really two simple machines kind of put together here. When you have a screw, a lot of times you'll see stamped on the box of screws or in like a CAD drawing, you'll see something that's called like a thread note. There's thread notes. So it might look something, you might see something like this, a whole bunch of symbols and letters and things. And there can be some other things too, but generally what this thread note, the way to read a thread note is this first thing is actually the diameter of the axle. So this diameter here would be like 1/2 inch. Really the most important thing we want to get is this number. This number here is called the TPI, which stands for threads per inch. It could be a TPC, that'd be threads per centimeter, but normally it's going to be like threads per inch. So like if I come over here and I measure 1 inch on here, then I would know that there's actually 13 threads per that inch. So if this was the thread note. This last thing here stands for like unified coarse, or it could be a UNF, unified fine. That just talks about how coarse or fine the threads are. So it's not really important for what we're trying to figure out here. So how do I find, as we're doing on all of these, how do I find the ideal mechanical advantage? We know that normally that's effort distance over the resistance distance. So what is the effort distance? Well, I would be trying to turn this thing up here, and like I'd turn it around maybe like 1 time. So I would turn the head of this screw around 1 time, and that would then be the circumference of the head of the screw. So I'll just put C in there for my effort distance. Well, what happens when I turn this around 1 time? Well, this screw goes into the hole. How far? Well, it would go 1 whole thread. So this is going to be kind of hard to do this, but I would go from that thread up to that thread. That amount of distance is how far in it's going to go when I turn the head of this screw around 1 time. It's going to go that far. What is that distance called? We actually have a term for it. It's called the pitch. The pitch of the screw is the vertical displacement between one thread and the next thread. Pitch. How do I figure out the pitch? Well, that is now related to the threads per inch. If I have 13 threads in 1 inch, then I can just flip that over, and the pitch will be 1 over the TPI, 1 over the threads per inch. So if I have 13 threads per inch, then the pitch is going to be 1/13 of an inch. 1/13 of an inch. To find the pitch, put 1 over the TPI measurement, the threads per inch. Unless they just tell you what the pitch is and you already have it, so that'd be nice. So the IMA is the circumference of the screw head over the pitch. So that's your IMA. It'd be C over P. The circumference that you turn this head around over whatever the pitch is. And that's how you'd figure that out. Now, what if we put a wrench on this thing, and so we have a wrench handle that goes clear out here? Well, then it'd still be the circumference, but you'd have to take, and how do you calculate circumference? 2 pi times the radius. Well, if it was just the screw head right here, it'd be the radius from here to here of the screw head. But if I put a wrench on it, it's going to be from here all the way out to, the end of this, the wrench, however long the wrench arm is going to be my R. So the screw's a little interesting to calculate. It can be a little difficult to get it all through, but it's going to be the effort distance, which of course would be, how far you're going to apply your effort, which would be the circumference of this thing out here, over how far it's going to go down into the hole, which of course is going to be, if you turn this wrench around one time, it's going to go from one thread down to the next thread. So it's going to be what we call the pitch. So effort distance over the pitch is your IMA. And of course, if we can figure out how much force we're applying in for effort and how much force it's taking to screw this in, we can still get an AMA the same way we've always done, FR over FE. Now, the mechanical advantages of these screws are huge. They're like ginormous, crazy numbers, like 90 something or whatever. Really, really big numbers. Huge mechanical advantage. Now, the efficiency is really bad. So if you take your AMA, which is going to be some huge number, still, it's going to be like some big number like 93. But over your IMA, to figure out your efficiency, your IMA would be something, it'd also be a ginormous number like 4,000 or something. Some really big number. You get huge mechanical advantages, but when you actually take your AMA over your IMA, you get really low efficiency. Really low efficiency. But that's good, because that means we're losing lots of energy or work. Why are we doing that? Because there's lots of friction. You lose a lot of work because of a lot of friction. But that's exactly what you want with a screw. You want there to be lots of friction, because what is a screw? It's a fastener. It's a fastener. So you don't want it to come loose. You want there to be lots of friction. So yes, the screw is not efficient at all because you're losing a lot of work through friction, but that's exactly what you want. You want there to be a lot of friction so that you can hold things together. It's a fastener. But the mechanical advantages are really, really big, and generally that's because there's actually two simple machines. There's a wheel and axle, and there's an inclined plane. So, ideal mechanical advantage, C over P. Circumference of the effort over the pitch of the resistance. The pitch is the distance between two threads. You figure that out by putting 1 over the TPI, 1 over the threads per inch, and you'll have your pitch. You might want to review that video a couple times. Sometimes that the screw simple machine is a little challenging for some people.